Hello everyone. So previously we looked into the certain applications of the quantum numbers. So there I talked about the orbitals, right? And now in this particular video, I'll be discussing about the shape that these orbitals have in the three-dimensional Cartesian coordinate. Okay, so when we talk about L value 0, okay, and with they would be representing the orbital of the type S. And these S orbitals have a three-dimensional spherical shape. Okay, three-dimensionally they are spherical in shape. So you can consider S orbital to be basically the ball with the center occupied by the nucleus. So spherical is the shape of the s orbital uh, in the s orbital. Okay, so if we now move on to the p orbital, okay, p orbital means when your L value is 1, then it represents your p orbital. So when it is a p orbital, the shape that it have is a dumbbell. Dumbbell is something looking like a dumbbell itself, okay, with a depression at the center. So this is a dumbbell shape. Okay, now as we discussed the magnetic quantum number, we have three different values for the magnetic quantum number given by your -1, 0, and +1. Okay, so that means your p subshell has three orbitals. Okay, and these three orbitals in actual are represented uh, as px, py, and pz. Okay, so if you want to represent in a three-dimensional Cartesian coordinate, so if this is your x-axis, this is your y-axis, and this is your z-axis, okay, then when you talk about px, then that means you have a dumbbell oriented along the x-axis. Okay, so that if you draw a dumbbell along the x-axis, then this particular p orbital is called your px orbit. Now you might be surprised about what do you mean by these plus and minus sign. These are important. In respect to one important fact is that this represents the face of the orbital, right? So during the mathematical calculations, these phase signs come on the dumbbells. Okay, so we will not go into too much of details about these phase sign rise because you do not have to study them right now. So just because we have to study their shape, so you should be aware that you have these plus and minus sign which represent the phase sign of these orbitals. So how can you remember it? It is very simple. See, when you draw the Cartesian coordinate, this particular part is, if you consider this as the origin of the Cartesian coordinate, this part is the positive x-axis and this corresponding is the negative x-axis. So the dumbbell that is coming on the positive x-axis would be represented by plus sign, and the one that is coming in the negative axis would be considered as the minus sign. Okay, so that is how this signs you can pretty easily remember. Okay, now coming to the py. Okay, so keeping the Cartesian coordinate in the same fashion, you have the x-axis, you have the y-axis, you have the z-axis. So when we are talking about py, that means this dumbbell is oriented along the y-axis. Okay, so if this is the y-axis, then the above part would be the positive part, and if we consider the intersection of the Cartesian coordinate to be 0, then the above part is the positive and this is the negative part. So accordingly, the phase signs on these dumbbells would be coming as positive and negative. And this is for your PZ. So now the dumbbell is oriented along the Z axis, and this part is your positive Z axis, so it would be plus, and this would be your negative Z axis. So this is how you, if you're asked to draw the shapes of the P subshell, you can easily draw them. So these are the various orbitals present in the P subshells. So Px, Py, and Pz or Pz. Now let us move on to the other L value, that is 2, which represent a subshell D. Okay, And as we know, since L value is 2, the various possibilities are -2, -1, 0, +1, and +2. So that means how many orbitals are possible? 1, 2, 3, 4, and 5. So 5 orbitals are possible in the case of d subshell. So which are the orbital? One is called dxy, dyz, dzx, and dx square minus y square, and dz square. Okay, so like I mentioned you, the shapes here is d orbitals have a double dumbbell shape, double dumbbell shape. Okay, that means there are two dumbbells, okay, intersecting. Okay, that is the usual shape of a d subshell. Okay, so it's very easy to remember. Just what are the combinations of d? So it is dxy, then dyz, then dzx. This comprises of they have a unique similarity in their shapes, and then these are the two odd ones. That is, one is dx square minus y square, another is dz square. Okay, now let us look into the shape. So let us first look into dxy. Okay, so for simplicity, we are not taking into consideration the z1. So if this is the x-axis and this is your y-axis, then your dxy, this particular diagram is the orbital for dxy. So your dxy would be something which is not along the axis, but it is kind of a dumbbell intersecting at the origin, but something along this xy plane. So it is happening in the xy plane. So this is your xy plane, that is the plane of this particular board. So along this plane at the origin, you have the intersection of these orbitals. Okay, now coming to the sign, very easy to remember. See, this particular axis is positive, this axis is positive, so positive into positive, it would be positive. Okay, now coming to this particular value, this particular lobe, this part is positive, this part is a negative part. So negative into positive would be a negative value. So that's why this lobe has come negative. Similarly, this one, this is the negative part, this is the negative part. So negative into negative, it would be positive. Similarly, this one is positive, this one is negative. So negative into positive would be a negative sign. So that's how the phase signs come very easily in this particular case. Now, if you want to represent for dyz, it is very simple. You do not have to follow the exact Cartesian coordinate. dyz means you have to draw it in the yz plane. So just for convenience, I'll rather than taking it as x, I'll take it as y, and the other one, it would be taken as the z, because I'm trying to draw dyz. So dyz means it's a double dumbbell in the yz plane. So I have to draw the y coordinate, Cartesian coordinate, and the z Cartesian coordinate. Now it's a double dumbbell shape. So we have the dumbbells intersecting at the origin. Okay, something like this. Now phase signs are pretty easy to understand. Positive, positive. So yz means positive into positive, it would be a positive value. Then positive into negative, it would be a negative value. Negative into negative, it's a positive value. Negative and positive, it would be a negative value. So this pretty easily represents. So try to draw now the shape for a dzx yourself. Okay. Now coming to dx square minus y square, it is very easy to remember. When you have a dx square minus y square, they also have a double dumbbell shape. Only thing is now the dumbbells are oriented along the axis. So you have, since it's x square minus y square, you have to draw only x and y. Okay, z is also present, but you don't need to show it. But even if you show it, it's perfectly fine. So this particular orbital, since it's in the x-axis, one is directed along the x-axis, another is directed along the y-axis. Okay. Now phase signs is also pretty easy to remember because it's x square. Okay. X square means even if it's a negative value or positive value, square of x would be always a positive value. That's why you have positive sides on both these ends. Now consider the y-axis. Y square would be positive, both a negative value or positive value. Y square will represent a positive value. But since it is superseded with a negative sign, that's why you have these lobes directed along the y-axis represented with a minus phase sign. So this is how you will draw the shape for the dx square minus y square. Now let us look into the dz square. Dz square is the only one that is little bit different from double dumbbell shape. Basically dz square, if this is the Cartesian coordinate, this is the y-axis, this is the x-axis, this is z-axis, then this z square means it is directed along the z-axis. One dumbbell is directed along the z-axis. Since it's z square, both the lobes would be positive. Then apart from that, there is a perpendicular ring, okay, a ring of electron cloud surrounding falling in the xy plane. So if this is the xy plane, it's a perpendicular plane passing through the paper. So on that perpendicular xy plane, you have a circular electron cloud ring, which you can represent it with an opposite phase sign, that is minus. Okay, so this would be the shape for a dz square orbital. So I hope you have pretty much understood the various shapes of the subshells and how the orbitals look in different subshells. We usually do not draw for the F subshell because it's a very complicated structure. So we limit ourselves only to the d orbitals, because most of the time the bondings that we have to show suffice with the d orbitals. So we do not have to look into the details of the f orbital to discuss about the bonding. So that is why we limit our understanding of the shape in your UG level to only d subshell. So thank you very much for your attention. Wait till the next video. Thank you.